Assalamualaikum girls. I am Shamsunnisa from Royal Degree College, Chemistry Department. As we are talking about Unit 2, Organic Chemistry, Chapter 1, Amines, Cyanides and Isocyanides. Today we'll see about nomenclature of cyanides, preparation of cyanides and chemical properties of cyanides. First of all, we'll see about nomenclature of cyanides. Cyanides are obtained by the replacement of hydrogen atom of Hessian by an alkyl or aryl group. First of all, we'll see about the common system of nomenclature. Cyanides are named in two different ways. First one is by attaching the suffix cyanide to the name of alkyl or aryl group. Example you can see here CH3CN. CH3 is methyl to which CN is attached. CN is cyanide, methyl cyanide. Another example is C2H5CN. C2H5 is ethyl, CN is cyanide, ethyl cyanide. Next example is C6H5, that is nothing but phenyl, to which CN is attached, that is cyanide, phenyl cyanide. As derivative of the acid, they give acid upon hydrolysis. In this system, the terminal ic acid or oic acid in benzoic acid or onic acid, propionic acid is replaced by suffix O-nitrate. Here you can see the example. CH3CN on hydrolysis gives acetic acid. So, CH3CN is named as acetonitrate. Here you can see the reaction CH3CN. In that we are adding the two water molecules. The reaction will take place in the presence of acid, that is H plus or OH minus. So we are getting here acetic acid, that is CH3COOH. How? Look at this. CH3, C is there. From that side, one nitrogen is coming out. In place of that nitrogen, OOH group is attached to the carbon. And we are getting here CH3COOH, acetic acid. And along with that, we are getting ammonia. How NH3 is coming out from this side nitrogen? It is coming out reacting with 3 hydrogens and we are getting ammonia. That is the side product. Next system is just now what we have seen, the common system. Now the second system of giving the name is IUPAC system. According to this system, cyanides are named as alkane nitrile by suffixing the word nitrile to the name of parent alkane. In naming the hydrocarbon part, carbon of the CN group is also counted. Here we can see the example. As it is written here CH3, CH2, CN. How many carbon atoms are present here? 3. We are giving the number to the carbon atom from this side. That is the carbon which is attached with the nitrogen. So 3 carbon atoms are there. So it is propane. N is nitrile. Propane nitrile. Another example you can see here CH3, single bond CH, then here CH3, then single bond CH2, single bond Cn. See here, in this, we are giving the number to the carbon atoms which are present in the straight line and start giving the numbers to the carbon atom from this side where the nitrogen is attached. This carbon is first carbon, then second carbon, third carbon. On the third carbon, CH3 group is attached. So we are writing here 3-methyl, means on the third carbon, methyl group is attached. And last one, this carbon is the 4 carbon. So 4 carbons are present in the straight line. 4 carbon is butane, to which the nitrogen is attached. That is nitrile. 3-methyl butane nitrile. This is the IUPAC name of this compound. Now we are talking about preparation of cyanides. First preparation is from alkyl halide. When ethyl bromide is heated with potassium cyanide in ethanolic solution, ethyl cyanide is formed. See the reaction here, C2H5Br, it is named as ethyl bromide, in which we are adding potassium cyanide. Reaction will take place in the presence of ethanolic solution and we are providing heat. Then what will happen here? This Br from ethyl bromide is coming out, reacting with potassium cyanide, and we are getting the side product as potassium bromide. And as the Br is coming out from this side, in place of Br, from potassium cyanide, Cn is going to attach there. It is substituted there. So we are getting here C2H5Cn. It is named as C2H5 is ethyl, Cn is cyanide. So ethyl cyanide. Next preparation of cyanide is from amides. Acetamide we are taking here. Acetamide when heated with phosphorus pentoxide. An amide gloss water molecule and forms methyl cyanide. Okay. So here you can see the reaction CH3CONH2. It is named as acetamide. In that we are adding phosphorus pentoxide. So here phosphorus pentoxide is acting as a dehydrating agent. Removal of water molecule will take place from acetamide. What will happen here? These two hydrogen atoms from acetamide is coming out, reacting with this oxygen, and we are getting the side product as water. Then the main compound is CH3 carbon, to the carbon nitrogen is attached. That is named as methyl cyanide. Next is benzamide. When heated with phosphorus pentoxide, lose water molecule to form benzonitrile. How we will see the reaction here? C6H5CONH2. It is benzamide. In that we are adding phosphorus pentoxide and we are providing heat. Then here also phosphorus pentoxide, it is a dehydrating agent, acting as a dehydrating agent. So removal of water will take place from benzamide. H2 is coming out, reacting with this oxygen, and we are getting the side product water. And the main compound is C6H5 carbon, to the carbon this nitrogen is attached. That is C6H5 is nothing but what? Methyl or phenyl. That is phenyl, C6H5, to which the Cn is attached. So phenyl cyanide, also named as benzonitrile. Next preparation we will see of cyanide, that is from aldoxin. Acetaldoxin, when treated with acetic anhydride, dehydrate to form methyl cyanide. Dehydrate means removal of water molecule will take place from acetaldoxin and we are getting the methyl cyanide. See the reaction, CH3 single bond CH, double bond and single bond OH. It is nothing but acetaldoxin, in which we are adding acetic anhydride. CH3CO taken twice O. It is acetic anhydride. So this acetic anhydride, it is acting as a dehydrating agent. Removal of water molecule will take place from acetaldoxin. Okay. So this OH is coming out, reacting with this hydrogen of acetaldoxin, and we are getting the water molecule. And what is left here? CH3CN. So we are getting here methyl cyanide. Now we will see the chemical properties of cyanides. First property is hydrolysis. Cyanides, when boiled with aqueous acid or alkalis, they get completely hydrolyzed to acid through the intermediate amide. Here you can see the reaction CH3Cl. It is named as methyl cyanide, in which we are adding water molecule. Hydrolysis reaction will take place in the presence of acid. Here the Cl we are taking and we are providing heat. Then here what is happening? From methyl cyanide, this nitrogen, it is moving slightly, it is moving this side, and in place of nitrogen, one oxygen from water molecule is taking its place. So we are getting here CH3CON. To the nitrogen, here the two hydrogen remains in the water, it is being attached to the nitrogen. So this intermediate compound we are getting here, it is named as acetamide. Okay. In acetamide, hydrolysis reaction will take place. We are adding the water molecule and we are adding acid also, hydrochloric acid, and we are providing heat. Here the HCl is also taking part in the reaction. What is happening here? From acetamide, this NH2 group is coming out. In place of NH2, to the CO, OH is going to attach from the water molecule here. So we are getting CH3COOH, acetic acid. And the side product is, see, NH2 is coming out from this side, reacting with one hydrogen here, okay. Then one more hydrogen from this side, NH4. Then this Cl, ammonium chloride. We are getting the side product. Another reaction we'll see. We are taking here C6H5Cl. It is named as phenyl cyanide. In that hydrolysis reaction will take place. We are adding water molecule. Reaction will take place in the presence of acid, HCl, and we are providing heat. Then from the phenyl cyanide, this nitrogen, it is slightly moving this side. In place of nitrogen, oxygen from water molecule is going to attach there to the carbon. So we are getting here C6H5CO. Then that nitrogen will attach. To the nitrogen, these two hydrogen atoms are going to attach here. So we are getting C6H5CONH2. It is named as benzamide. This is the intermediate compound. In benzamide, we are adding water molecule and hydrochloric acid and we are providing heat. Then in the benzamide, from benzamide, NH2 group is coming out. Okay. In place of NH2, from water molecule, OH is substituted here. So we are getting C6H5COOH. It is known as benzoic acid. Okay. And another product, what we are getting here, this NH2 as it is coming out, reacting with one H from water molecule, one H from HCl, that is NH4. Okay. And this Cl is going to attach. And we are getting ammonium chloride. Next one we will see, that is with Grignard reagent. Methyl cyanide when react with methyl magnesium bromide. Methyl magnesium bromide is nothing but Grignard reagent. It forms an intermediate compound. That intermediate compound undergoes the hydrolysis to give acetone. So we are taking here CH3CN, that is methyl cyanide. In that we are adding CH3MgBr, that is methyl magnesium bromide. What will happen here? See, look at this. CH3CN is there now. So in understanding in between carbon and nitrogen, triple bond will be there. One of the bond is going to shift the upper side of the carbon. Okay. To which from methyl magnesium bromide, methyl group is going to attach with that bond. Then here remains double bond nitrogen. Okay. With the nitrogen, this MgBr is going to attach. This is an intermediate compound. This intermediate compound undergoes hydrolysis reaction. We are adding the two water molecule in it and this reaction will take place in the presence of acid, H+. So what will happen here? This NMgBr, this whole group, it is coming out from this side and to the double bond of carbon, one oxygen from one water molecule is going to attach with the carbon. Okay. Then we are getting the main product, that is CH3, single bond C, then single bond CH3, double bond O, CH3CO, CH3. It is named as acetone. And the side product also will get, as this MgBr, NMgBr is coming out. Now, first of all, MgBr will come out and Mg and Br is moving apart and in between Mg and Br, from one of the water molecule, OH is taking place. Okay. So we are getting MgOHBr. This is the side product, magnesium hydroxybromide. Along with that, we are getting one more side product, as the nitrogen atom is coming out from this side, reacting with 3 hydrogen, and we are getting the ammonia, NH3. Next chemical property we'll see, that is reduction. On catalytic reduction, a cyanide is completely converted into amine. See the reaction. CH3CH2CN. It is named as, here the 3 carbon atoms are present. So propane, nitrogen is attached. So it is nitrile. Propane nitrile we are taking. In that we are adding sodium alcohol or lithium aluminium hydride. They are acting as a reducing agent. Reduction will take place in propane nitrile. Reduction means here we are writing 4 nascent hydrogen. Then what will happen here? Here in case of the propane nitrile, CN is there now. From this side, this nitrogen, it is moving, slightly it is moving. In place of that nitrogen to the carbon, the two hydrogens are going to attach there. And we are getting this one CH3, single bond CH2, CH2, then nitrogen. And to the nitrogen, here the two more hydrogen remains. It is being attached with the nitrogen. So NH2, CH3, CH2, CH2, NH2. It is named as 1-propanamine. Why it is 1-propanamine? Where the amine group is attached, NH2 group is attached, that carbon is considered to be as the first carbon. Okay. At the first carbon, NH2 is attached. Altogether, how many carbon atoms are there? 3. So 1-propanamine. It is named as. Next reaction we'll see C6H5CN we are taking. It is nothing but phenyl cyanide. In that we are adding two hydrogen molecules. Reaction will take place in the presence of nickel or platinum. So here what is happening? The carbon to this particular carbon of phenyl cyanide, the two hydrogen from this side is going to attach. Then nitrogen will attach. To the nitrogen, another two hydrogens are going to attach with the nitrogen. So we are getting C6H5CH2NH2. It is named as benzyl amine. C6H5CH2 is benzyl. NH2 is amine. This is our main product. So cyanides are converted into aldehydes when they are partially reduced to aldimine hydrochloride, followed by steam distillation. The reduction is carried out by treating cyanide in ether solution with stannous chloride and hydrochloric acid. This reaction is called Stephen's reaction. See the reaction, we are taking stannous chloride, SnCl2. In that we are adding 2 moles of hydrochloric acid. What is happening here? The 2 chlorine from the hydrochloric acid is going to attach with the SnCl2. So we are getting SnCl4, stannous tetrachloride plus 2 nascent hydrogen. The 2 hydrogens are coming out and it is in the form of nascent hydrogen. Those 2 nascent hydrogens we are taking in the next step. It is being added to the methyl cyanide. Reaction will take place in the presence of hydrochloric acid and at room temperature. Okay. So what is happening here? To this carbon of methyl cyanide, 1 hydrogen from this side is going to attach. Okay. Then nitrogen will attach. To the nitrogen, 1 more hydrogen is going to attach along with HCl. Okay. This is the addition product we are getting. CH3, single bond CH, double bond NH, HCl. It is named as aldimine hydrochloride. This aldimine hydrochloride in the presence of water undergoes the steam distillation. Then see here very carefully from this side CH double bond and HCl is there na, and HCl it is coming out from this side. To the double bond here oxygen from the water molecule is going to attach. So we are getting this aldehyde. It is named as acetaldehyde, CH3CHO. This is the main product. Then the side product is this nitrogen is coming out, okay, reacting with these 2 hydrogens remain here and the 2 hydrogen from the water molecule. So altogether hydrogens 4 and H4. Then this here, ammonium chloride. We are getting the side product. Next one we will see 4th reaction, that is oxidation. Here the formation of ester will take place. When an alcoholic solution of methyl cyanide is heated with concentrated sulfuric acid or hydrochloric acid, the ethyl acetate, which is nothing but ester, is formed. See the reaction here. CH3Cl, methyl cyanide. In this we are adding ethyl alcohol, C2H5OH, ethyl alcohol, and we are adding in that water also. The reaction will take place in acidic medium and we are providing heat. Then here what is happening? See here, methyl cyanide is there na? From methyl cyanide, from this particular carbon, this nitrogen is coming out. Okay, in place of nitrogen, first of all, from water molecule 1 oxygen is going to attach with that carbon. Then in the next step, OC2H5 from ethyl alcohol is getting reversed and going to attach turning and attaching to that oxygen as OC2H5, that is CH3COO C2H5. C2H5 is ethyl, CH3COO is acetate. We are getting ethyl acetate, it is nothing but ester. And along with that, this nitrogen is coming out from this side now, reacting with three hydrogen, two of the hydrogens from water and one hydrogen from ethyl alcohol. So we are getting the side product as ammonia. Thank you for listening my lecture, guys.